Good morning children. Today we are going to study chemistry subject for 10th standard ICSE, right? And the name of the chapter which we are going to study over here is electrolysis, right? This chapter electrolysis comes under the branch called as electrochemistry. Now what is electrochemistry, that we need to understand, and then we have to understand electrolysis is that branch of the chemistry where the electrical energy and the chemical energy, they are interrelated, or the chemical energy has to get converted into electrical energy, or electrical energy has to get converted into chemical energy. The vice versa conversion will be going to take place in that branch. Now this electrolysis will come under that branch, right? So wherein the chemical energy has to convert it into electrical energy. We have been already studied in physics as well as the chemistry subject. Energy can neither be created nor be destroyed, but it can be transferred from one form to the another form. Similarly here, the chemical energy has to convert it into the electrical energy. The chemical energy will not going to get destroyed. In fact, the chemical energy has to convert into the electrical energy via a process called as electrolysis. Now this term electrolysis means what? Here the lysis means breaking. Right? Here the breaking of electrolyte will take place. That is the meaning of the word electrolysis. Now what is electrolyte? We will study here. But you have to understand, you should have the hint of what is electrolysis is all about. Electrolysis is nothing but it is divided into two sub-words. Electrolysis. Lysis means breaking. Breaking of what? Breaking of electrolyte. And what is electrolyte? We'll understand in much more deeper, right? Now here electrolysis, what is there? That is a specific definition for it, right? It is a process of chemical decomposition, So here chemical, whatever the chemical ingredient we are using over here, this chemical ingredient may be in the solid state or in the liquid state. So when I talk about the solid state, all the molecules will be togetherly held over here, whereas in the liquid state the molecules will be far apart from each other, because you know it that you have studied in your 8th standard that the solid particles are attracted with each other with certain force of attraction over there, right? So here in the liquid state, the force of attraction between the molecules are less, right? So thereby in the liquid state the molecules are little far apart from here in this way, right? So it is a process of chemical decomposition. So whatever the liquid chemical or the solid electrolyte which we are going to use in the form of a molten, right, semi-solid kind, here the chemicals will start decomposing. Why the chemical has to decompose? Because they have to convert into the smaller. The molecules are decomposed into atoms, and the atom has to get converted into ions. You know this very well, the interrelation, right? Because the molecules are nothing but they are present in the matter, right? And the molecules are made up of atoms. Atoms in turn made up of ions, right? So this ion has to get splitted out, right? So electrolysis is nothing but what? It is a decomposition of that molecule which is present in the liquid state or in the solid state. So this liquid state molecule has to get decomposed to set free the ions, because these ions are responsible for passing the electric current, right? For the flow of any electric current, we need certain medium. We need certain ions into that. These ions are responsible for the flow of electric current into it, right? So what the definition says, let's understand once again over here. It is a process, it is a phenomena where the chemical decomposition, of chemical ingredient of the electrolyte. This electrolyte is very, very important word. This electrolyte has to decompose. And this electrolyte may be in the liquid form, as I said, maybe it is in the solid form. This has to decompose, present in the molten, see here, molten in the sense semi-solid or other dissolved state. Dissolved state means a liquid form, a solution form, by passing an electric current through it. So whenever the electric current has to flow into the liquid medium, there should be certain medium, right? So suppose if any contaminant water is there and short circuit happens into that contaminant water, what will happen over there? There the current will start flowing into that water, start passing into the water. Why? Because that contaminant water will be having so many muddy particles, so many ions which will carrying that electron, the electric current will be flowing into it. Now in your home, the electricity, when you on the electricity, light and bulb and whatever it is glowing off, right? Why it is so? Because we have certain metal wire, copper wire. This copper wire is helping the electron to flow into it, right? So this copper wire is nothing but it is a medium through which the electron is flowing, right? So similarly in electrolysis process also, the chemical is a medium, and that chemical they are taking in the form of a dissolved state or the molten state. This chemical has to get decomposed for the electron to flow into it, and after decomposing, what they are setting free is the ions, right? So dissolved state, the solution which is having the molecules into it, that molecule first they have to break into the atoms. Atoms in turn they will break into the ions. These ions are helping out for the flow of electrons into it. So what is electrolysis, dear? Electrolysis is nothing but it is a process of chemical decomposition of the electrolyte. Here the electrolyte will be going to get decomposed to set free the ions, and these ions will pass the electrons or the electric current through it, right? So here what is happening over here? The chemical means the electrolyte, which is a chemical energy, is converting into the electric energy, right? So electrolysis is a process of converting chemical energy into the electrical energy by decomposition of chemical ions into it, by setting a electron to flow into it. So that was all about the electrolysis. So you should understand the word electrolysis first, and you should understand what it says about, or what is the definition or the process is all about, right? So that was all about the electrolysis. Now we'll understand the conductors, right? Conductors. Now what are conductors? Conductor means not bus conductors, okay? Here conductors means in any medium, right? Any medium which may be solid, liquid, either to this state of a matter, they will be helping out to conduct electric current, right? So here what happens? The substance which conduct electric current, the substance which conduct electric current when present in one form or the other are called conductors, right? So conductors are those substance, those state of matter which is helping out for the electric current to flow into it. For example, again I will take the same copper wire into your home, which is connecting through the wire through the board, main switch board, and to the source like light source. So who is conducting electric from the board, the electric board, to the switch or to the source of light? The medium which is called as copper wire. This copper wire is nothing but what it is, right? The copper metal is nothing but it is a good conductor of heat and electricity, we say. Or we can say it is a good conductor of electricity. Why we say good conductor of electricity? Because it is supporting the flow of electron into it. Understanding? If any substance is not helping out for the conduction of electric current, that substance we are not saying that it is not a conductor. We say in fact it is an insulator which is not helping out for the conduction of electron. But conductors are those substance which conduct electric current into it, which conduct or which support or which help the conduction of electric current into it, right? So that's are called as conductors. Here now we are going to study about the conductors. Now we already studied or we know about the conductors. Conductors are the substance which are helping out for the conduction of electric current, or any state of matter, maybe in the solid state or in the liquid state, they are helping for the conduction of electric current into it. Now these conductors are classified into two types, or the conductors are categorized into two types. First one is metallic conductor, second one is electrolyte. I repeat once again. First one is metallic conductor, second one is electrolyte. Now first we'll emphasize upon the metallic conductor. Now what is metallic conductor is all about? What is metallic conductor is all about? The name only suggests that metallic means the conductor which is made up of metal, right? So metallic conductors are nothing but these are the substance which conduct electric current. Obviously, if I say conductor means they have to conduct electricity, but the state of matter will be very into it, right? So these are the substance which conduct electric current in which state? In the solid state, right? So metal is a solid, right? Whichever metal you take, copper, aluminium, iron. So these are the solid state of matter, right, which is in the solid state. So at the same time, these are not chemically decomposed. This is very, very important statement, children. These are not chemically decomposed. These are the substance which conduct electric current. Though they are conducting electric current, which is at the solid state, but most important point over here is that they are not chemically decomposed. The metals whichever you are using in the form of a bar, rod shape, ball shape, irrespective of the shape, whichever shape they are using the metal, this metal will be not decomposed. They are not chemically decomposed. Decomposed means they are not going to get degrade, right? The state of matter will be the same. No chemical decomposition of that state of matter will be there, right? So that is the most important point over there. So what is metallic conductor? Metallic conductors are the substance which conduct electric current. In which state? In solid state. And what is not going to happen over there? They are not going to get chemically decomposed. This metallic conductor are not going to get chemically decomposed. This is the most important point over there. Now let's understand with the help of examples. Now examples are copper metal. Copper is very fantastic example for the conduction of electric current. Now copper, it is in a solid state, right? So when you are using copper as a metallic conductor, there the chemical decomposition of a copper metal will not going to happen. Understanding the point? So copper, silver, gold, lead, graphite. So these are the metallic conductor which is used in the solid form, and there chemical decomposition will not going to get happen, right? So that's what all about the metallic conductor. Now second one is electrolyte. Second one is electrolyte. First one we covered, which is metallic conductor. Second one is electrolytes. This is the most important, conductor wherein we are going to use in the electrolysis process. Now what is electrolytes? Now this electrolyte, obviously they are also going to help for the conduction of electricity. We are saying that these are the conductor, these are the two types of conductors. So when I talk about the conductor means they have to conduct electric current, right? So if I talk about the electrolyte will also conduct electric current, but the state of matter will vary into it, right? So these are the substances which conduct electric current. But what will be the state of matter of the electrolyte? It may be in the solution form or molten form. Maybe in the solution form. Now what is solution? What is solution? Solution is nothing but it is a combination of solute and solvent, right? Wherein the solute will be in the form of a solid or liquid form. The smaller part of the solution, solvent is the larger part of the solution. For example, salty water. If I take salty water means what? It is a solution, where salt which you are adding into the water, that is considered to be the solute. And the water which you are taking, it is a solvent, right? You are aware of this word wherein you have been already studied in 9th standard. I repeat once again, what is solution? Solution is a combination of solute plus solvent, right? For example, salty water. Now salty water, here the salt which you are suspending into the liquid medium, so called water, that salt you are putting in a smaller amount. Therefore salt is considered to be the solute. Whereas the liquid medium which you are taking in a larger proportion, that is water, and it is considered to be solvent, right? So this electrolyte will have the state of matter in the form of a solution or molten state. Now molten state will be that state wherein the solid particle, the solute particle will have the breaking, the bond between them, they will start breaking when you supply the heat to it. For example, NaCl again, Na and Cl. Na means what? Sodium. Cl means chloride. So they are having ionic bond between them, right? There are two types of bond: ionic bond, covalent bond, or one more is there, that is different one. So ionic bond is a very stronger bond. When you supply the heat to it, it needs large amount of energy to break that bond. So when the two ions will be going to get set free that time it will convert into the aqueous state. So that is nothing but molten state. I repeat once again, what is molten state? Molten state is that state wherein the large amount of heat energy has to be supplied for that particular ionic solid, right? So when you supply heat energy to that particular solid, that two atoms will set free to convert into the ions, and that ions will conduct electric current into it, right? So that is a molten state which will be obviously taking place in the aqueous solution. Aqueous means aquaguard. Aquaguard means the water purifier. The water will be going to come out of it, right? So NaCl is nothing but NaCl, sodium chloride, the common salt. When you suspend into the water, that will convert into the aqueous state. The basically molten state it is. So what it is all about, these are the substances which conduct electric current. In which state? Solution state. I described what is solution. And or the molten state. What is molten state? That also you people know now. And at the same time, the most important point over here, at the same time these are chemically decomposed. At the same time these are chemically decomposed. Now this is electrolytes which is helping out for the electrolysis to take place, right? So electrolysis means what was happening? The electrolyte has to decompose. So how they will decompose? By chemically they will decompose. So suppose if this is the container, in this container the solution is this, NaCl solution. Let's take NaCl solution, right? Sodium chloride, salty water again. So this Na has to set free and Cl has to set free. The ions will be segregated as positive ion and negative ion. And these are nothing but cation and anion. That will later on study, right? So when they are set free, these ions are helping for the conduction of electric current. So thereby this is nothing but chemical decomposition. That electrolyte NaCl solution has to decompose, has to degrade to set free those ions. When they will set free the ions, these ions will conduct electric current. Understanding the point? So what was the electrolyte? Electrolyte are the substances which conduct electric current in solution form or in molten state. But at the same time, these are chemically decomposed. If these are not chemically decomposed, they will be not set free into the ions. And if the ions are not set free, the electric current will not obviously going to pass over here, right? But in metallic state, it's not like that. If they do not chemically decomposed, no worries, because the metal are the purest form or the good form of conduction of electricity. But in the solution form, this is basically in the liquid form. If the ions have to set free, if the ions are not set free, nobody will be there for the carrier of electric current. Here the metals are carrying the electric current, but in solution somebody should be there to carry electric current, no? So therefore the ions are there, which is in the form of a positive ion and negative ion. And how these ions will be formed? By chemically decomposing that electrolyte, right? So this is the phenomena of electrolyte or the process of electrolyte. For example, let's take NaCl. NaCl is the most strongest electrolyte. NaCl means sodium chloride. Sodium chloride, common name for it is common salt. Common salt, when you suspend into the water, what will happen? It will happen as salty water, correct? Now this is hydrogen chloride or hydrochloric acid. This is also used as one of the electrolyte in the solution form. Then this is NaOH. NaOH means sodium hydroxide solution. Sodium hydroxide solution. So this they are taking basically in the aqueous solution, aqueous form or the solution form, wherein the passage of the electric current should take place into that liquid medium. So here we covered with the topic, important topic, so called conductors and the type of conductors. Now what are conductors? The substance which conduct electric current, right? Wherein the conductors are broadly classified into two types, metallic conductor and the electrolyte. Now what was metallic conductor? Metallic conductors are the conductors wherein they are helping out for the conduction of electricity or electric current, but in which state? In solid form, right? Solid, metal are in solid state, right? So in solid state only the electric current will be going to pass over there. But at the same time, the most important point over there is this metallic conductor will no more chemically decomposed. Here no chemical decomposition of the metallic conductor will be going to take place, because they are the purest form for the conduction of electric current into it. For example, copper, silver, gold, and apart from that lead, graphite, etc. These are the example for the metallic conductor. Whereas electrolyte, these are also the conductors, but these are helping out for the conduction of electric current, but in which state? Solution form or molten state. Solution means it is a combination of solute plus solvent, whereas solute may be solid, liquid, or solvent should be absolutely in the liquid form, right? Or in the molten state, and in the aqueous state. At the same time, the most important point over here, at the same time, the chemical decomposition should take place. If the electrolyte is not chemically decomposed, the ions will not going to get formed, and if the ions are not set free, the electric current will not going to get passed into it, right? For example, for this is common salt solution, that means a salty water, hydrochloric acid, sodium hydroxide, etc. These are the example for the types of the conductors. And the two types of conductors we studied was metallic conductor and the electrolyte. Those two are nothing but conductors. Now exactly opposite to electrolyte, we are going to study about non-electrolyte. What was electrolyte was doing? Electrolyte was helping out for the conduction of electricity, but the state of matter of electrolyte was in the solution form or in the molten state. And one specific point was there. What was that? That they are going to chemically decompose. The chemical ingredient wherein they are used in the solution, they are going to chemically decompose, right, in electrolyte. But in non-electrolyte, it is exactly opposite, since here the conduction of electricity will not going to happen, or it will not going to take place. How come? Let's study over here. The substance which do not conduct electric current, the substance which do not conduct electric current in the molten or dissolved state are called as non-electrolyte. The substance which will not going to conduct any electric current, the state of matter will be same, either in the solution form or in the molten state, right? So here the conduction of electricity will not going to take place in this state of matter. Thereby this substance is considered to be non-electrolyte. For example, urea, sucrose, fructose, glucose, etc. These are non-electrolyte because they are not helping out for the conduction of electric current or electricity over there, right? So that was all about the metallic conductor, electrolyte. They are the conductors. They are helping for the conduction of electricity. But here the exactly opposite to the electrolyte is non-electrolyte, which will not going to conduct electric current. Example is urea, sucrose, fructose, etc. Now we are going to study about the new concept, new topic, which is very, very important, and that is electrodes, right? What is the name of the concept over here is electrodes. Now what this electrode is all about? Electrodes are nothing but it is a pair of rods. It is a pair of rods, right, or plates. The shape may be in the rod shape or maybe in the plate shape, like this. The rod shape or basically thick plate, like this, right? So these are the pairs, right? A pair of rods or a pair of plates. So this is plate, this is rod. So these are the electrodes, right? It is a pair of rods or plates of what? Metals. They will be in the form of metals, right? Metals, either in the shape of rod or in the shape of plates, right? This plate will be or metals will be in the form of a copper, graphite, lead, etc. dipped into the molten or dissolved electrolyte, right? So these are the electrodes. These are the electrodes which has to be dipped into the dissolved solution. The dissolved solution was electrolyte, right? What was electrolyte? Which was conducting electricity, right? So this electrodes has to be dipped into this electrolyte. So the names are really very confusing. You don't have to confuse anymore here. This is electrodes and that is electrolyte, right? And what is electrode? Electrodes are nothing but a pair of rod shape or plate shape metals which has to be dipped into the electrolyte. So this has to be dipped into electrolyte. This electrodes has to dip into the electrolyte, right? Okay. After dipping into the electrolyte, what will happen over there? Right? Dissolved electrolyte through which the electric current enters or leaves the electrolyte, right? So through this electrodes only, now electric current will pass from this electrolyte and they will enter into this electrode, right? So whatever the electric current will supply from electrolyte, it has to enter into electrodes. Now what was electrodes? I'll repeat once again. Electrodes are nothing but a pair of rod shape or plate shape. Where it has to be located? It has to be dipped into the dissolved state or dissolved solution or molten state of electrolyte, right? So this electrode has to dissolve into the electrolyte, and through this what will happen? Whatever the electric current will supplied from the electrolyte, they have to enter into the electrodes. So electric current will supply from electrolyte to electrode, right? Or it will enter from leaves from electrodes to electrolyte. So there is an interconversion between or intimate connection between the electrode and the electrolyte. So this electrode has to dip into the electrolyte, right? If they are not dip into the electrolyte, whatever the electric current is passed from the electrolyte, they will not enter into the electrode. Understanding the point? So from this electrode, again they have to go back into the electrolyte, like a circuit diagram. See, now this is a container. In this container, if suppose this is the two rods, if suppose this is the two rods of electrodes, what are those? Those are electrodes, right? So in this from this electrode, this has to be dipped into the electrolyte. So what is this? The liquid medium? It is electrolyte, right? So this electrode has to dip into the liquid medium called as electrolyte. So whatever the electric current is supplying through ions, this electric current has to enter first into the electrode. Through electrolyte, the electron will enter into the electrode, and from electrode it will again leave into the electrolyte. So it is a closed circuit diagram. Closed circuit diagram from electrolyte to electrode, again back from electrode to electrolyte. So closed circuit diagram, a circle, merry-go-round, how it just rotate in a circular form. In the same way, the electric current will be also circulating in the circular form, right? First from electrolyte to electrode, again from electrode to electrolyte, right? So this is the process of closed circuit diagram. Okay, so that was all about the electrodes. Now these electrodes are classified into two types. There are two types of electrodes. First one is anode, second one is cathode. First one is anode, second one is cathode. These are the two electrodes. These are the two types of electrodes wherein they have to dip into electrolyte. Now this, what does the anode will do? Two electrodes are there, no? So one will be anode, second will be cathode. Like this it will be named as, right? One electrode will be anode, another electrode will be cathode, right? So what does the anode will do? What is the function of anode? What will happen in the anode, right? So the electrode connected to the positive terminal of the battery and at which oxidation take place. Here anode will be, these two electrodes will be connected to the external source of battery. Battery connection should be there, right? So this anode will be connected to the positive terminal of the battery. Anode will be connected to the positive terminal of the battery. And here, which process will take place? Oxidation. Which process will take place? Oxidation. You have to remember only one thing is that anode is one electrode which has to connect it to the positive terminal of the battery. So like this it is, right? And here what will take place is oxidation. And what is oxidation is all about? Oxidation is a process of loss of electron. Oxidation is a process of loss of electron, right? So which will take place at the anode. I repeat once again, anode is the first type of electrode, right, wherein it will connected to the positive terminal of the battery, at which oxidation process will take place, and what is oxidation is all about? Oxidation is loss of electron. Oxidation is, here I will write, loss of electrons. Loss of electron will take place at anode, right? Now cathode is a second electrode. And exactly opposite to anode is cathode, right? Cathode will be connected to the negative terminal of the battery. And here what will take place? Here reduction process will take place. What will take place? Reduction process. Reduction means gain of electron. Here I will write down. Gain of electron. So gain of electron is nothing but reduction. So anode and cathode are exactly opposite to each other. Now anode means what? It is the first electrode. Where it is connected to the positive terminal of the battery. And what will happen into the anode? Loss of electron. Loss of electron means oxidation. Cathode will connected to the negative terminal of the battery. And what will take place over there? Here it will take place reduction. To be very frank and to be very simplest form, if I want to make you to remember, always keep anode as lone. L-O-A-N, lone. Abbreviation. How you have to remember? You are not supposed to write in exam, but it is for you people to remember at anode what will happen. Anode is nothing but loss of electron. Loss of electron means oxidation, right? This is anode. A stands for anode. At anode, loss of electron is taking place. That means oxidation is taking place. Then anode is connected to the positive terminal. This here it is positive will come, but this one you don't have to remember. Exactly opposite P. You have to remember. Understanding? Because anode, near to anode, anion will go. Right? So anion is negatively charged. So N will stand for negatively charged ion. So here you have to remember P. Instead of N, you have to remember P. But two things you can remember from here is that at anode, loss of electron is taking place. That means oxidation is taking place. But it is connected to the positive terminal of the battery. Instead of N, P will be there, which will be connected to the positive terminal of the battery. Right? So that was all about the electrode. Now what we studied in this repetition is that first one is that non-electrolyte. Now what was all about the non-electrolyte? Non-electrolyte is a substance which do not conduct any electric current. For example, urea, sucrose, fructose, glucose, etc. Right? Then after that we studied about the electrodes. Now what are electrodes? Electrodes are nothing but they are the pair of rod shape or plate shape which has to immersed or dipped into the aqueous solution, that is into the electrolyte. So this electrodes has to dip into the electrolyte. So the electron will start flowing from electrolyte to electrode and again from electrode to electrolyte. So closed circuit diagram will be going to get happen wherein the flow of electron will take place. Now this electrode will be of two types. Electrodes are of two types. First one is anode, second one is cathode. First one is anode, second one is cathode. Anode is connected to the which terminal of the battery? Anode is connected to the positive terminal of the battery. And in this electrode what will happen? At this electron, the loss of electron will take place. That means oxidation process will happen. For example, I had given LOAN. N you don't have to remember. N basically will be given because that it is a different concept where the negative charge ions will going to take place over there. That means anion. Right? So L stands for loss of electron. O is oxidation process. A stands for anode. Right? And instead of N, what will come? P. P means what? It will connect it to the positive terminal of the battery. Whereas cathode is connected to the negative terminal of the battery where the reduction process takes place. And reduction is exactly opposite to the oxidation. In oxidation what will happen? Loss of electron. Whereas in reduction, gain of electron will happen.